first? Is that how it is? Okay. So first guy first sheet. So when you have these weird fractional exponents, they work the same exact way as regular exponents. Do you remember all your exponent rules? Are we going to be adding, subtracting, multiplying, or dividing those powers?
Adding those powers?
Yeah, exactly. So as weird as those exponents look, you're just going to be adding them. So keep the same base, add the exponents, and you're going to get 5 to the 6/3.
Oh, so you keep the denominator.
Yeah, keep that base the same, right? Like if you had x to the 5th times x to the 3rd, that'd be x to the 8th, right? You didn't do anything with that x, right? So don't do anything with that 5.
Okay.
Yeah.
And that's when you just multiply it, when you're multiplying the...
Yeah, okay. So I've got, so all your rules, if you have the same base and you're multiplying, you're adding the powers. If you have powers, 2 powers, like that, you've got superpowers and you multiply those guys.
Oh, okay.
If you're dividing, come on. If you're dividing, you're subtracting.
Mm-hmm.
And if you're dividing, you're still subtracting. If you get a negative, what maybe you can keep it like that, or you can rewrite those negative exponents as just pushing it to the other side of the fraction.
Yeah, I always got confused with this.
So these are all your exponent rules, and all of those are going to hold no matter what wackiness they throw at you.
Mm-hmm.
So first one seem okay?
Yeah, that was pretty easy.
Oh, good. We'll take it. And then, so number 2 is going to work the same exact way. So what's the exponent on the 3 that we're too lazy to write?
1.
Yeah. And so what are we going to do with those exponents? Add, subtract, multiply, or divide?
Subtract.
Yeah. So we got 1/2 minus 1. And 1/2 minus 1 is negative 1/2. Yeah. And they don't say how they'd like you to leave your answer. So did she give you an answer key?
No.
Okay. So general rule of thumb is like if they give you your initial problem with fractional exponents, you're welcome to leave your answer with fractional exponents. But if you started off with radicals, you would put it back into radical form. So I'm okay leaving it like that. If you don't like the negative exponents, some teachers have you write it with only positive exponents and put it down there. So this is also fine. If you wanted to put it with a radical, you could put it like that, but they didn't start us there. And if you go there, you don't like radicals in the denominator, so you'd have to rationalize it, which we'll get to later as well. But it's one of the reasons, like, do we have to go there? I don't want to go there. So everything boxed is a potential
answer
way you could leave your answer. Yeah. So, yeah. Okay, cool. And yeah, so we do it again. So that guy there, what are you going to do with those exponents here? Add, subtract, multiply, or divide?
Multiply.
Multiply them, yeah. And it's just a matter of multiplying fractions. You remember what you're going to get or how that's going to work?
You would have to make the denominator the same, wouldn't it?
Multiplication, you don't need to, right? Multiplication is so much more forgiving than adding and subtracting. You don't need common denominators to multiply. You're welcome to either multiply straight on across and then simplify later, or you can just notice that those 2's cancel and take you straight to there. Okay. And I'm happy leaving the answer like that. Yay, so fun, so fun. So we keep going. So this one is annoying. Why is this one annoying? What's wrong with it?
Oh, the bases are different.
Bases aren't the same, exactly, right? So normally you just go, oh, bases aren't the same, can't do anything. But in this case, the exponents are the same. So that's the thing too. If those exponents are the same, you can kind of pull that out. We're a little bit more used to going backwards. Like if you had 3 times 4 to the 1/4, you would say it's 3 is being raised to the 1/4 and 4 is being raised to the 1/4. So normally we kind of go in that direction.
Mm-hmm.
But you're welcome to go the other way and say that this is 12 to the 1/4.
So you just leave it there if the base is the same.
So if the exponents are the same, yeah, you can kind of multiply those insides together.
Okay.
And that's a thing. And so, yeah, you're welcome to leave your answer as 12 to the 1/4, which I kind of like because the beginning one started off with fractional exponents. If you wanted to, you could put it back if it's multiple choice or something and they had that, that's equivalent.
Yeah.
Looks good. All right, keep moving.
Yeah.
Right. All right. So this is nice. They both are cube roots. You can multiply the insides together. That's okay. They're both the same index. Totally all right. And we happen to know what this is. What's the cube root of 8? Not 8 cubed. So it's not 8 times 8 times 8. It's what cubed gives you 8.
Oh, 2.
Yeah. That's good.
Oh, so that would.
You want to make whole foods, hot foods, right? Tonight.
Yes. Cool. All right. Yeah, so this chapter, it's like, welcome back. There are lots of little rules, lots of little, yeah, they're a little messy, but it's okay. All right, this guy, the same way we were able to multiply insides together if they have the same index, you can totally divide.
Just divide it?
Yeah, they have the same index. They're both fourth roots, just divide. So 240 divided by 15, that's 16. So then you're looking at the fourth root of 16. And we happen to know that. What to the fourth power gives you 16?
2?
It's 2, yeah. So when you have to guess small because they get big fast. Yeah. And that's it. Still good?
Yeah.
All right. So for this one could say that it's done because it's not as bad, not that bad as is. But I think what they want you to notice is that the bases are the same. So I can rewrite this with a fractional exponent as 3 to the 1/3. So is that looking familiar? That's, we haven't, that if you have that, that's 3 to the 1/3. Cool. And then this bottom is 3 to the 1st. And now when you write it like that, you're like, oh, we've got the same base. What can I do with those exponents? Add, subtract, multiply, or divide.
Subtract.
Subtract, yeah. So you've got 1/3 minus 1. So when you're adding and subtracting, that's when you need a common denominator. So you've got 3 to the negative 2/3.
Okay.
And I think they want you to leave it here for this one. You could do 1 over 3 to the 2/3. So that's fine if you don't like the negative exponent. If you were to put it back into radical form, because I was tempted, it's like it started with a radical form.
Mhm.
So maybe I'll write it with the radical form. It's the cube root of 3 squared. Yeah. So you could write it as 1 over the cube root of 9. But if you went all the way and did this, a lot of teachers don't like radicals in the denominator.
Mhm.
So if you rationalize the thing, you get all the way back to
Oh.
there, right? Which is why in the beginning I'm like, well, that's pretty good right there. So the chapter is a little bit frustrating. And I know some textbooks treat it very, very poorly. Like sometimes they'll leave the answer like this, sometimes they'll leave it like that. And it's really annoying. So hopefully your teacher is clear which way she'd like you to leave your answer. Being able to play, though, and realizing that all these forms are equivalent are going to help with like SATs and things like that. And just they're all the same. So being able to play is fun. But knowing where they want you to stop is sometimes very annoying.
Yeah.
So yeah, I'd probably leave it at this guy.
Okay.
Yeah. Any questions so far? Anything I keep saying that you're like, yeah,
No,
that is good?
Yeah.
All right, cool. So, yeah, this guy's nice. So we're a little bit more comfortable with this notation. Although we kind of wish they had taught us this first, because having to go back and forth is kind of a pain. But we learned this first, so it's okay to split them up. We know these. What's the cube root of 64? What do you raise? It's a little bit bigger, but if you had to guess, like it's... Yeah, 12 is way big because 12 times 12 is already 144. You want to go small. So, because you're... And if you were to check it, like if you were just to punch it in, like what might you want to check smaller than 12?
3.
3. So if you did 3 times 3 times 3,
It's 27.
27. So a little bit too small. Go a little bit bigger.
7.
So 7 times 7 times 7, too big.
Oh, 4.
4 is good. 4 times 4 times 4 is 64.
Okay.
Yeah. Mm-hmm. And then if you had to guess for the bottom, what cubed gives you 125?
5.
5. Yeah, that's our guy. So that's 4/5. Yay. And your calculator can do some of this. What kind of calculator do you use? Do you have one like that?
Yeah.
Something like that? So it can do, you see that little yellow X the root?
Yeah.
So you can do 3 first and then second X root of, make sure you have parentheses, 64 over 125. And it will give you 0.8, which if you wanted to change to a decimal, you could do fraction to decimal. So if you had that 0.8 and you wanted to do fraction to decimal, you use second fraction to decimal. And it gives you 4/5.
I didn't even know it showed fractions.
Yeah. So that F to D in that yellow, you can go back and forth.
Oh, okay.
Mm-hmm. Yeah, and then the one underneath it, if they ever give you an improper and you want a mixed or a mixed improper, it'll toggle back and forth. So if you had like 5 divided by 4 and they give you 1.25, you do that, it gives you that, but you're like, who does mixed? Yeah. So you hit mixed to that, and you get backwards. So lots of stuff that we can do, but we're pretty good on our own. So many problems.
I know.
And they're all just a little bit mixed up, but that's okay. So So,
Oh, wait.
so yeah, back to this. What are you going to do with those exponents? Add, subtract, multiply them, or divide them?
Multiply.
Multiply them, yeah. And so do you remember how you can multiply those guys? What you're going to get? Mm-hmm.
1/3.
1/3, yeah. So I am totally cool leaving it there because that's how it started. And if they had radical form, it'd be the cube root of 10. So both of these look clean. Woohoo! So that's their first section. And then they're on to their next section, which will have a bit of mix of what we're doing and a bit more. Yay. All right. Oh, okay. So I think before we do that, she kept them all perfect. Yes. Awesome. So we don't need to do anything. So square root of 9x squared. Super nice. We know what the square root of 9 is. That's just 3. We know what the square root of x squared is. That's just x. She doesn't. Do you remember? Is she going to make you put absolute values on them?
I don't think so.
Because technically, there should be some absolute values here. And she didn't tell us. Sometimes they'll say, like, assume everything is positive, and you can just go, okay, fine, you don't need them. So I'm not going to worry about those yet. And then if we have time at the end, I'll circle back and tell you when to put in absolute values and when you don't need them. But right now, I'm happy with that. Yay. Let's take it. And so then we have the cube root of 2x cubed. And I don't know what the cube root of 2 is. That's not pretty. But I know that the cube root of x cubed is just an x. Okay. So he'll come out, and the 2 will have to stay in, and that's that. Okay?
Yeah.
All right. Yeah. This worksheet is a little random, but I'll do it. And so now we're back to this.
So you would add them?
Exactly. Yeah. So 2/3 plus 1/3 is?
So just like.
Yeah.
You just leave it?
Oh, 2/3 plus 1/3 is how many thirds? 3/3. So just 1? Just x?
Yeah.
Yeah.
Okay.
Yeah. It's a long way of saying, yeah, it's just x. Just x, and that's as good as that gets. Okay. And then this guy we can do, because that's the same thing. If you have 1/2, that's the same thing as the square root. I don't know what the square root of x is, but I do know that the square root of 4 is 2. Oh. Yeah, so both the top and the bottom are being square rooted.
Yeah.
So take out whatever you can, leave whatever else inside. Excellent. And so it's the same thing for this one. It's going to be the 4th root, 16x, And earlier we figured out that the 4th root of 16 was 2. And then, but I don't know, the 4th root of x is just going to be the 4th root of x. Busting through. Seem okay?
Yeah.
All right. Okie dokie. So they have the same index, so we're okay to multiply the insides together. So I'm not exactly sure what 27 times 9 is right now, but I'm just going to leave that. But what's x times x to the fourth?
X to the fifth.
Beautiful, yeah. And so that x to the fifth root of that is just going to pop out as an x. And then 27 times 9, I'm thinking that might be perfect. I'm going to break this guy up. 27 is 3 times 9, and that's 3 times 3, and 9 is 3 times 3, right?
So 3 to the fifth.
3 to the fifth, right? So if you take the fifth root of 3 to the fifth, that's just a 3. Mm-hmm. Yeah, so it's the fifth root of 3 to the fifth, x to the fifth. So on your calculator, you could have done 27 times 9 and made it very big, and then just tried to guess your way there and go, oh, yeah, that's 3 to the fifth. Mm-hmm. But sometimes if you don't have a calculator, or you're like, I think something pretty is happening.
Yeah.
And that's that. Sweet. And keep going. Yeah. So what might be a beautiful first step for this thing?
Just dividing the 12 and 3.
Yeah, let's do that. And what's that going to be?
2.
Mm-hmm. And the square root of x squared is just?
X.
X, yeah. 2x.
Okay.
It's as good as that gets. Mm-hmm. Yeah. Sorry, he's doing his bicep curl, so that's he's all right. One of my students like, okay. Yeah. So now we're back to these. What do you want to do with those exponents?
Multiply.
Mm-hmm. Yeah. So what do you get? Mm-hmm.
Sorry.
No, you're fine.
Is that negative 3?
Yeah, so negative 1 over 3, yeah.
Negative 1 over 6.
Negative 1 over 6.
Oh,
yeah, I think you accidentally
flipped
flipped that
it.
one over, yeah. Okay. Keep that guy upright.
Negative 2 over 3.
Negative 2 over 3 is great. And now, if you have a negative on the bottom, you can just push it, the negative in the exponent on the bottom, just push it up to the other side. Oh. So any negative in the exponent will just push it to the opposite side of a fraction. Sometimes I like to think of it as he's unhappy down here, but he's happy up there.
If it's in the denominator?
It'll scoot up to the numerator. Okay. If it was ever in the numerator, it's scooted down to the denominator, right? So when we had like this guy, we scooted him down there.
Okay.
Yeah. So it's just unhappy where it is, push it to the other side. And then for this one, they do say to leave your answer in simple radical form. So they want the radical form. So the denominator controls the index. This is the cube root. And then the power does what the power always does. It's the cube root of x squared. Yeah. And you can leave it like that.
So the denominator is always the one that goes outside.
Yeah, the denominator is your index, right? Because that's what we learn, right? That's the cube root is the cube root, and the fourth root is the fourth root. And then if you have like that cubed, it's like, oh, it's that cubed,
Okay.
yes. Yeah, so I think you can handle this one. You can use the calculator to guess what the fourth root of 256 is.
Four.
Gorgeous, yeah. So that's going to pop out as a 4. And then how are you going to write the rest of it? Anything else popping out with it?
X or Y?
Yeah,
Y.
just the Y, right? The X, that 4 can't see the X, right? So
Uh-huh.
if it were X to the 4th,
Okay.
then I could take it out. But he's not to the 4th, so he's going to have to stay in there. But the Y will come out.
Okay.
And then the X will have to just stay in.
Okay.
That good?
Yeah.
Excellent. Yeah, you seeing the same thing I'm seeing? Just that? All right. So what do we do with those exponents? Add, subtract?
Just
Just add them, yeah. So if you're looking at 3 plus root 5, that is as good as that gets.
Oh.
They're not like terms. They don't have the same square rooty part. Can't do anything. So just leave it there. That's it. It's weird that she says to leave your answer in simple radical form, because I'm not going to even attempt to put that as a radical thing. Yeah. I would just leave it there. Yeah. Yeah, so you can handle this one as well. What are we going to do with those exponents?
Multiply.
Multiply them, yeah. So what's root 3 times root 3?
9.
Root 9. And what's root 9?
3.
Back to 3. Yep. Good. That is odd looking. And at this stage in your math career, I don't know if you have seen enough of these to know what's odd looking and what's not, right? Like all of this probably looked a little odd, right? But this feels particularly odd. There's not a whole lot you can do with this. Yeah, nope, because if it were like 4x to the half, right, then you could make it that, right? But you're not gonna change that, and it's not gonna be pretty. I'm just gonna skip this and go, yeah, maybe there's a typo or something. I'm not seeing anything particularly great that's gonna make that good. So skip. So don't worry about them.
Okay.
You have enough on your plate with the rest of it. Yeah, and then we skip from 21 to 25. That's fine with me, a few less. And now we're doing something a little bit different, but it's very nice. If you're adding, and no matter what, if you're adding, you're just adding like terms. So if you have 2 cube roots of 3 plus 1 cube root of 3, you've got 3 cube roots of 3.
So you don't add the...
Don't change the middle, right? Because if you had like 2x's plus 1x, you have 3x's, right? Not 3x squared or anything weird. Just treat it just like you've always treated like terms. And so, yeah, so same deal for the next one. So what do you think you're going to get for this guy?
Sorry.
No, don't. I'm writing it too. You're perfect. Don't let me rush it.
Would you add, if they're the same, and the inside, would you add the 15?
Same thing as this guy. So like if I had, So the idea is like if I had 8 square root of 3's plus 2 square root of 3's, I'd have 10 square root of 3's, right? So they are like terms. You have -3 of these plus 2 of those. So how many of those do you have?
Would it just be -1?
Yeah, -1 of those.
Okay.
So you can drop the 1 if you want and just write negative that. But yeah. Ta-da. Yep. Yeah. And then 27, same deal.
Just 5. Or no, wait.
Here.
8. And then
Yeah. So 8 of those. And I don't mind leaving it like that because that was the form that was given in. But if you wanted to put that in radical notation, it might look a little bit better. So how could we rewrite this with the little root?
3 on that outside. And then...
yeah, so it's the cube root of 2. And it's just 8 times it, yeah. Ta-da! Looks good. We keep going. Okay. So this one, why are we a little upset about this one?
The 8 doesn't have...
Yeah, so it doesn't look like they match. So it looks like, oh, we can't do anything. But we haven't simplified square roots yet. So do you remember how to simplify? We haven't done it today together yet, but have you ever simplified like the square root of 8 and made it 2 root 2?
Yeah.
Yeah. So do you have a way that you like to do it, or do you want me to show you?
Could you show me?
Yeah. So there are 2 ways of doing it. I'm going to show you the tree way. Did you ever do the trees where you break them up?
Yeah.
And you can break it up however you want. So I'm going to do 8 as a 2 and a 4 and a 2 and a 2. And because this is a square root, I'm going to take out groups of 2. So anybody who gets paired up, one representative from that group will come out. And anybody who didn't get paired up does not get to come outside.
Okay.
Yeah. And we'll get lots of practice with that, I think, as we go. Yeah. So way more. So now this will be 4 root 2 minus 2 root 2. And they're like, now we have like terms. So 4 roots of 2 minus 2 roots of 2. 2 root 2 is gorgeous. Yep. That's good. So 29, we get to do it again. So it looks like they're not like terms, so it looks like we can't do anything. But if we take that 40 off to the side, and we start breaking them down however you want. So how do you want to start breaking down your 40?
8 and 5.
8 and 5 sounds great. And then the 5 is done, and we can break down the 8.
And 2 and 4. And then 2 and 2.
Beautiful. And so now, since it's a cube root, we're going to take out
3
groups of 3. Yeah. So one representative from that group will come out, And anybody who didn't get grouped will have to stay inside. So this will be 2 cube roots of 5 plus another cube root of 5. So how many cube roots of 5 do we have?
Would it be 3 cube roots of 5?
Yep. Gorgeous. Excellent. Let me do it again. Yeah, so you want to practice breaking down that 96. You can use the calculator as much as you want. Or maybe you don't need to. How do you want to break up a 96?
12 and 8.
12 and 8, yeah. Brain's a little rusty after the break. I'm like, 96?
Yeah.
Oh, yeah, 12 and 8, that works,
Yeah.
yeah. And let's keep breaking them down. And now, since it's a 5th root, we take out a group of 5. So, hey, look, it's 5 2s. And so, do you know what it's going to look like when we finish simplifying?
2 root 3.
Yeah. So we got 2, 5th root of 3, and then minus 4, 5th roots of 3. And so overall now we have
-2 5th root of 3.
Yeah, -2 5th roots of 3. It's a mouthful. Excellent. On to the back. Is it good?
Yeah.
All right. Mm-hmm. So the 32, you can do just like we've been doing. So let's do that with a tree. Oh, you can bring it up however you want.
Oh.
You'll get to the same place no matter where you start.
Oh, okay.
Mm-hmm. So here we have a couple groups of 2, right? And so one representative from each group will come out, and when they do, they'll multiply together. So we'll have a 2 times a 2. So we'll have 4 on the outside, and then the one little lonely 2 will have to stay on the inside. Now, when we go to deal with the x to the 5th part, what we're doing is we're dividing. We're doing 2 goes into 5 twice. And then there's 1 left over. So x is going to have to stay in. And then I should put the 4 from our 32 and our 2 in there. Yeah. So it's a little bit annoying because like some stuff is going to come out and some stuff is going to stay in. So sometimes we have a little bit of extra spacing, but that's okay. We'll just push it all together at the end. So do it with your numbers separate, tree that. And then with your exponents, you're just dividing by that index, and the remainder will remain inside.
Okay. How do you know it's a 2 over there?
Yeah, when you're doing with square roots, it's just because we're too lazy to write a 2. Right?
Oh, okay.
Yeah, and then the next one is going to be a 6th root, so then they'll have to write it.
Oh, okay.
Yeah. So many questions in math would be answered if we were just not too lazy to write zeros and ones and just having all these little shorthands. And it makes sense when, it's like, oh yeah, it's nice not to write that. So the 128, we'll just tree that.
2 red, 2.
Gorgeous. I forgot my little 6th root. Don't forget that. It's easy to forget. All right, 6th. And then, so I guess the way I feel like doing it today, I'm going to have the 2. I'm going to leave a big space and put the 2 on the inside. And then if I need to smush things back together at the end, I will. So I'm going to do 6 goes into 8 just once with 2 left over. And then for the Y's, 6 goes into 11 just once with 5 left over.
Oh.
Yep. So they're just little remainder problems. It's just little tiny division, just like you did in elementary school, but it's like, yeah. Yeah. And then if you wanted to, you could ditch the 1s and kind of smush things back together because mine got a little stretched out. Looks good. Yeah. Yeah. So I'm kind of looking ahead and I think we've kind of hit most of the main ideas now, which is awesome. We've got a good 18 minutes left, so I guess we just keep going. Is that all right?
Yeah.
Yeah, I think we're on track. Come on, pen. You can do it. This one. All right, so my pen might have died. It'll come back in a few minutes, but yeah, so go ahead and try this one. I'll stop this for now.